Okay, everyone, we have arrived now at the last lesson of this unit, which is in regards to similar triangles. So obviously, this lesson, we are just dealing with the shape of a triangle, nothing else. Now, similar triangles are very useful in making calculations and determining measurements, but there are certain little facts that you need to ensure that you have in place before we move on. Now this one's the easy one. Obviously a triangle always has three sides and three angles. But an important part is, please remember that the three angles inside of a triangle always equal 180. Therefore, if you know two of the angles and you don't know the third, you can easily find that out. So keep that in mind. I'll just draw you a really easy example here, okay? If I said to you that this angle right here was 30, and I said to you this angle right here is 90, and that's very much part of the trigonometry unit and so on and so forth. And I said to you, well, how much is this angle up here worth? All you would have to do is go 180, take away the two other angle measurements, take away 30, take away 90, and that would give you 60. So you know that this angle right here would have to be 60 degrees. And again, if you did the math on that, if you went 60 plus 30 plus 90, you would get yourself back up to 180 degrees. Now, this is also important. If two corresponding angles are equal, the third angles will also be equal. Now, this is important. What the heck are they trying to say to you? What they're trying to say is, and please apologize my terrible drawing. Actually, maybe what I'll do is I'll just cheat into example 1 down here below. Let's pretend that this angle right here is 60, okay? And let's put this one right here, I'll put it as 20, okay? Well, let's also assume then that, I'm just making this up here, everyone. This angle right here, I'm telling you, is also going to be 60, okay? And I'm saying to you that this one here is 20 degrees. Now, what did that little thing say there again? It says, if two corresponding angles are equal, the third set of angles will also be equal because they equal to 180 degrees. Now, that kind of sounds like a mouthful. How about we put it to you this way? You see, this angle is equal to that angle. This angle is equal to this angle. What I'm simply trying to say to you is this third set, as in this one right here and this one right here, they also must be equal. And how could you figure out the measurements of that? Well, if you look over here, we know that there are 180 degrees inside of every triangle. So if I go 180, take away 60, take away 20, I know that this where I put the X is 100 degrees. Therefore, we know, based on what we just talked about here, this angle must also be 100 degrees. So long story short, if you know two matching angles, this is equal to this, and this is equal to this, the matching angles must also be equal. Okay, now let me get rid of all that writing there, because of course you can rewind and watch that again if you so choose. We're moving down here. There are several special triangles. An isosceles triangle has two sides equal in length, and the two angles opposite these sides are of equal measure. An equilateral triangle has all three sides equal in length and all three angles equal in measure. So let's do an equilateral first. Now again, please, I apologize for my drawing. So if I did this perfectly, an equilateral triangle, what did it say? All three sides are equal in length. So if I did this perfectly, if this was 5, this would be 5, and this would be 5. But what else does it say about an equilateral triangle? It says all three angles would be exactly the same, and they would be 60 degrees. 60, 60, and 60. And again, if you do your little check there, because remember, the angles inside of a triangle have to equal up to 180 degrees. And if you go 60 plus 60 plus 60, you will get up to 180. So that's an equilateral. An isosceles triangle, okay, it says there that an isosceles triangle has two sides equal in length. So let's go like this. Okay, so these two sides are going to be equal in length. So that means if I said to you this one was 10 and this one is 10, they're equal in length. The bottom one, that's not the case. This might be 20, let's say. Okay? And the two angles opposite these sides are of equal measure. So what does that mean? How about, long story short, this? Okay, you have three angles. What it means is, when they say angles opposite, what that means is, if I said to you this was 40 degrees, that means this would be 40 degrees. And how do I work that into the definition? Because it says there, and the two angles opposite these sides. Well, just so you know, this angle right here is opposite of this side. And this angle right here is opposite of this side. So you see, here are your equal sides, okay? And it says the two angles opposite of those sides. So here's your equal sides, here's an opposite angle, here's an opposite angle, they must be equal. If I do that for you here again, just to try to drive this point home, I'll do another one. Okay, so let's say this time this is 200, 200, and this one down here I'll say is 300. So we have an isosceles triangle because we have two sides that are equal. But it also says that the two angles opposite of these sides must be equal. So you see, this angle right here is opposite of that side. And this angle right here is opposite of that side. And based on this definition, both of these angles must be equal because they are opposite of the equal sides. So if someone told you that this was 60 degrees, this one also must be 60 degrees. And just in case someone asked you, you could figure this out right here. Okay, now, two triangles, let's move on to the next part. It says, two triangles are similar if any two of the three corresponding angles are congruent, or one pair of corresponding angles is congruent, and the corresponding sides beside the angles are proportional. Congruent means the same in shape and size. That sure is a mouthful, but let's see if we can break that down here a little bit. Okay, two triangles are similar if any two of the three corresponding angles are congruent or same in shape and size. So let's look down here at example one. Let's try to break this down a little bit. If you look here, you're looking for kind of signals. You see, they put an X right here. They put an X right there. That means those angles are equal or congruent. Do we see any other shaping here that means equal? Well, yes, we do. We see this right here and this right here. So we know that angle B is equal to angle M. We also know that angle C is equal to angle N. Based on this definition, we know that these two triangles are now similar because they have two sets of matching angles. Well, and if you want to push it, actually every angle will be the same because based on what we talked about above, these ones will be the same now too. So based on that ruling, we know that we have similar triangles. There was two sets of matching angles. Then there was this one here. It says, or one pair of corresponding angles and corresponding sides. Let's keep moving along here. Now you see, the point is you have to keep testing all of this out. Try to find matching things. So if I put this together for you, we'll call this case one. Whoops. Case one. And what I'm going to do right now is I'm going to pause this video because I'm running out of time and come right back.